Here's the first equation. We're going to solve it. We're also going to check it. Remember that when you're solving an equation, the whole goal is to get what by itself? The variable. I'm going to circle where the variable is, and I'm going to look at what's attached to it. Notice I circled the 2x. I didn't just circle what? The x. It's being multiplied. I've got to get rid of the addition first. I've got to kind of go backwards through the order of operations because I have to undo what's taking place. So I'm going to go backwards through the steps. I'm recording it, so I'd rather we step through it one piece at a time. And I'm recording it so that if you go home tonight and you don't know how to do it, you could go back and play the video clip. Okay? There'll be a video clip on my website. Just pull it up if you don't remember how to do it. All 4 examples will be recorded. It is. Everything that I've said, everything that's up here, just like the video that you watched in class, this is how I record it.
Wait, so it can hear us, I can see?
Some, but it's going to hear me mostly because the microphone is right here. Okay? I have to get rid of this 5. It's being added, so I subtract. Whatever I do to one side of an equal sign, I have to do to both sides. The 5s on the left are going to cancel out, leaving me just 2x. 11 minus 5 is 6. I still want to get what by itself? The variable. It's being multiplied. The opposite of multiplication is I divide both sides by 2. These 2 would cancel out, leaving me x equals, and 6 divided by 2 is 3. If I check my work, I go back to my original equation. What can I put in place of x? 3. So I take 2 times 3 plus 5 equals 11. And I want to make sure both sides come out exactly the same. I have to do the 2 times 3 first. That's 6 plus 5. And what is 6 plus 5? 11. So I know that I came up with the right answer because my answer checks. Question?
Couldn't you just like guess and check on here?
I could, but I'm going to tell you that if you get in the habit of guessing and checking, are you going to be able to guess and check your way once they throw decimals in? How about fractions? But this method will work how much of the time? All the time, if you keep undoing what's happening to the variable. That's why we learn to solve them this way. It's not that guess and check is a bad mathematical method. It's usually slower because you might have to guess 1,000 times before you get to a right answer. Right? This one, the numbers are small. What would have happened if the numbers were much larger? You want to guess and check your way through it then? Not likely. So you understand the process. Everybody got this first problem copied?
Do we have to write on the test?
I would have written it down. So I got to wait?
I wrote everything that you.
If I take the time to write it on the board, where would I put it? If I were you? I'd put it in my notes. There's a reason for me writing it down.
I always do. I just whatever you put on the board, I just write
Okay, next problem, go ahead and write it down.
We're doing the same thing.
We're going to do the same thing. What are we going to do?
Solve.
We're going to solve, and we're going to check. What do I want to get by itself? I look at where the variable is, and I get rid of the part that's attached to it. How do I get rid of the addition? I subtract. Be careful when you're dealing with this many negatives. This is really a -2. This is also a what? -2. They both have the same sign. So when I put them together, I'm going to keep their sign, and I'm going to add the two numbers together. 2 plus 2 is 4.
Wait, but why would you, oh, because you're adding, okay, I get it.
Are you with me?
Yeah.
Oh, there are two negatives.
Yes. We all right?
I thought you said two negatives make a positive.
When you're multiplying, two negatives make a, but when you're adding and subtracting, two negatives make a bigger negative.
Isn't it like the bigger number?
Like signs, you add and keep the sign. These are both what? Negative. I have to keep their sign. It's going to be negative, and I add 2 and 2 together, which is 4.
But what if it was like +2 and -3?
If it was +2 and -3, I'd keep the sign from the -3, because 3 is larger, and I would take 3 minus 2, which would be 1. It would be a -1. Okay? I want to get this y by itself yet. It's being multiplied. The opposite of multiplication is division. Please, it's being multiplied by a -4. Make sure that you divide by a -4. A negative into a negative is going to make a positive. In other words, these are going to cross out and make a positive 1y, or just y. -4 divided by -4 would be what? +1. If I come over to check my work, -4, y plus 2 equals a -2. What am I going to put in place of y? 1. -4 times 1 plus 2 equals -2. What is it, -4 times 1? Here's the question you just asked. Do these two numbers have the same signs or different?
Different.
Which one has the larger absolute value?
-4.
I have to keep the sign of the -4, so it's going to be negative. And 4 minus 2 is -2. And I can see that my answer checked.
What is that thing?
What? The arrow?
No. That.
Here?
Yeah.
That's an arrow too. I said which one was larger? The 4 or the 2, the absolute value. I have to keep the sign, which means my answer is going to be what? My answer was going to be what? Negative. That's what I was pointing to.
Why is that underneath the 4?
I just said which one was larger, 4 or 2, right? And which one was larger? The 4. That's why I circled it. It has a larger absolute value.
I thought that it was simply negative, it would be smaller.
It is smaller, but its absolute value is what? Larger. And that's what I'm looking at. Its absolute value. Can I go on yet? No. Good.
Are we doing something different now?
A little.
So he's still
We're still solving, right?
doing the same thing?
Doing the same type of thing. Still solving. Write the example down. This just looks different. But the process is the same. Listen, I have to get what by itself? The variable. I work through order of operations backwards. What's the beginning of order of operations? Parentheses. Next is what? Exponents. Next is multiplication and division. Next is addition and subtraction. Look, the variables inside of these parentheses. I'm going to leave the parentheses alone for a minute. The negative 3 is being multiplied by the parentheses. How do you get rid of multiplication? So the first thing I have to do is divide both sides by a negative 3. What's going to happen to the negative 3's? It's going to leave me n plus 5 equals. A positive divided by a negative would make a negative. And 3 goes into 12 how many times? 4. Because I wanted to get rid of what? The negative 3 that was out in front. It's being multiplied. How do you get rid of multiplication? How do you get rid of multiplication? Division. That's why I had to divide here. That's correct. No. If I had divided by a positive 3, this would have still been a negative out in front. I want a what? A positive. Okay, now? I still want to get what by itself? The variable. How do I get rid of the adding 5? Subtract 5. Do the 4 and the 5 have the same signs? Yes, they're both negative. It's going to make a larger negative. 4 plus 5 is 9. Okay? I'm not going to check this one for the sake of time. If I plugged it in, it would come out right. Negative 9 plus 5 would be negative 4. Negative 4 times negative 3 would give me a positive 12, and I can see that that's what I came up with. Are you okay? What's the whole goal in solving an equation? To get what by itself? The variable. To get the variable by itself, we undo the order of operations. Can I go? Who said no? You're good? Go ahead and copy the last example down. This is why we don't guess and check. Okay? You're going to guess and check your way through this one?
Yes.
Not likely, right? It's going to be difficult to guess and check our way through it. Listen. Listen. We do the same process. Nothing changes. But how? What do I want to get by itself? So, how do I get rid of addition? Did that change from what I did before? No. What makes this one look so much harder? It's got decimals and it's got a fraction in it. Okay? Makes it look harder, but I'm going to tell you the process is the same. It's okay to use this. It's okay to put a calculator to this. I'm going to take 47.2 and I'm going to subtract 81.9. Should my answer be positive or negative?
Negative.
It should be negative.
Positive against negative. And then
It's a negative 34.7. And it's equal to this, k over 5.2. What do I want to get by itself?
the variable, so you get
The variable.
5.2.
What's happening to k at this point?
That's five.
It's being divided. And to undo division, we use. So I multiply both sides by 5.2. What happens to the 5.2s on the left? They cancel out, leaving me just k. And I take my negative 34.7, which, by the way, is still in my calculator, right? And what do I do?
Is that negative?
Yes. No, no negatives.
By the K.
No negatives. Negative 180.44. Why? What's harder?
Big number. I don't know how to do it.
What do you use? A calculator. Did the process change? No. Don't let decimals or fractions make you think that the process is different. If you can do it with little numbers, you can do it with big numbers. The process is the same. That's the nice thing about math. You don't have to learn 20 exceptions to the rule. You learn a rule, you study the rule, you apply the rule. Done. Questions?
Somebody traced a binder on
I see that. I'll do my best to answer. Mhm.